Hello everyone, my name is Tia Bilali and I work as a project manager with Creative Thinking Development in Greece. Today I will be introducing you to the life cycle analysis and its mostly common used tool, life cycle assessment, which is a tool for assessing the environmental footprint of a product or a service. However, before moving on to the life cycle assessment, it is important to understand the definition of it. So what is a life cycle assessment? It is a technique that is associated with a product by compiling an inventory of relevant inputs and outputs, evaluating the potential environmental impacts, and interpreting the results of the inventory and impact phases in relation to the objectives of the study. It is important here to mention that there have been many life cycle case studies in the textile sector that have been performed, but many of them have not been published. However, the ones mentioned here are easily accessible to the audience. Starting with the method presentation of the life cycle assessment, there are 4 phases of a life cycle assessment. The first phase is the goal and scope, which is the definition by intended application, audience, publicity, functional units, allocations, data quality requirements, type of critical review. Moving on to the life cycle inventory, which is consisted of inputs and outputs of the system unit, raw material inputs, emissions to air, energy inputs, and many more. The third stage is the impact assessment of the life cycle, which is coming from the selection of impact assessment method. The selection of impact categories are the indicators, the characterization models, the results classification, grouping and normalization, or weighting. Final stage is the interpretation of the results and usability of the impact assessment and the life cycle inventory. For the goal and definition, we have the typical studies that aim to reduce CO2 emissions, meet certification, or reduce energy use. The data quality for the analysis is very important. According to ISO standards, data parameters are the reliability or the completeness or temporal correlation, geographical and technological correlation. In the phase 2 of the life cycle assessment, the inventory analysis, this is where the data collection analysis is taking part. Each unit in the flow diagram below must be explicitly described in order to ensure understanding better between the LCA actors and avoid overlaps. Here we have the life cycle of smart textiles, the inputs coming for the manufacturing of the textiles and the outputs coming to the environment after the manufacturing of the garment. It is important to understand the phase 3, which is the impact assessment of a garment. For example, for a pair of Levi's jeans, we have here emissions of 3,781 liters of water used, while CO2 emissions coming to 33.4 kilograms during the life cycle of a pair of Levi's jeans, while the average life of a pair of Levi's jeans is 3 years. In this stage, we are evaluating the significance of the impacts. Common impact categories like human toxicity or global warming potential, ecotoxicity or acidification are factors that require the indicators that we want to use for the life cycle assessment. Classification, where every stage in the flow diagram is classified in every indicator. And finally, we have the impact measurement, where all equivalents are calculated. The final phase is the interpretation. It is a decision phase where the results are interrogated, compared with each other, and in order to improve the environmental footprint, it is also important to compare the solutions between the systems that are being compared. In conclusion, it should be made clear that a good and accurate life cycle assessment requires a lot of effort and expertise, and it cannot be accomplished unless the person that it's being grounded for that is an expert himself. The method is not self-optimized and it needs human intervention in order to access alternative solutions or to drive towards optimal choices. Thank you very much for listening to this resource.